Welcome to Go with the Code. In this video you will learn how to create, read, update and delete data from the database using ADO.NET, Dapper and Razor Pages. But as always, you should know what you do before you do it, because you do it at your own risk. In this video we will use the database model that we created earlier. If you haven't seen previous videos yet, please watch the videos. First, you need at least one connection string before you can connect to the database. The connection string must contain the database server instance name, database name and login information. If the database is installed to the default instance, the instance name is same as the computer name. ASP.NET Core Web Application includes app settings file, which contains the connection string to the database. Here we have created a connection string to the database. The connection string name is default SQL server. With ADO.NET you can connect to the database and create, read, update and delete data from the database. ADO.NET is fast because it executes raw SQL statements on the database. Because the SQL statement is not automatically generated, you have to know how to write SQL. ADO.NET contains SQL client library, which you use when you communicate with the Microsoft SQL Server database. In most cases, you use SQL connection, SQL command, SQL parameter, SQL data adapter and SQL data reader class with ADO.NET. Here we can see the steps that we need when we update data in a database using ADO.NET. First we write an SQL statement. Always use parameterized SQL commands and queries to avoid SQL injections. Next, we create a connection to the database and create an instance of an SQL command class. Before you can execute an SQL statement on the database, you must first open the connection. Always use using statement to dispose an SQL connection and SQL command object. You will get a return value or result set when you execute a command or query on the database. Next, we can see how to update an existing table row from the database using ADO.NET. In this example, we have created a method that specifies parameters and an SQL command that we will execute on a database. The method sends the SQL command and parameters to the execute command method. Execute command method instead represents a connection to the database, creates an instance of an SQL command class, sets command text and the connection. The default connection timeout in this example is 10 seconds. The connection timeout should never be too long. The method also defines parameters, opens a connection to the database and uses execute non-query method to execute SQL command on the database. The method also disposes the instance of an SQL command and SQL connection class and returns the number of rows affected. We can use execute non-query method with update, insert and delete commands. We can also use ADO.NET to retrieve data from the database. Usually with ADO.NET we use dataset, data table, data column, data row and data view class, which are part of the system data library. Dataset contains data tables, data table contains data rows and data columns. You can also use SQL data reader to retrieve data from the database. Dataset can also be created manually, but when you retrieve data from the database using ADO.NET, the dataset is created automatically. Next we can see how to retrieve data from the database and fill the result into the data table. You can also fill the result into the dataset. When you use dataset, you should have an SQL query that contains at least 2 select statements, which are separated by a semicolon. In this example, we have created a method that retrieves a single person from the database. The method declares parameters and SQL query and sends the SQL query and SQL parameters to the getDataTable method. The only difference between getDataTable method and executeCommand method that we saw earlier is that getDataTable method uses SQL data adapter class to fill the result in the data table. In this example, we can see how to use the result. Because we retrieved only one person from the database, the data table contains only one row. The data table contains columns that we declared earlier in our select statement. In this example, we set the result to the instance of the person class. You can also retrieve a single value from the database using a select statement. When you want to retrieve a single value from the database, use executeScalar method. In this example, we insert a new row into the database table and use selectScopeIdentity expression to retrieve newly added row ID from the database. We use executeScalar method to retrieve a single value from the database. executeScalar method returns the value of the first column of the first row. Next we will see what is Dapper and how to use it. Dapper has better mapping capabilities than ADO.NET. You use Dapper to connect to the database and create, read, update and delete data from the database. Dapper runs on top of ADO.NET. The result can be mapped to the strongly typed object. Dapper simplifies things. Dapper is a 3-step process. First you create an IDB connection object, then you write a query to perform create, read, update and delete operations, and finally you pass the query as a parameter in the execute method. Dapper contains methods. With methods you can execute SQL commands and queries on the database. Dapper also contains parameters and results. You can use results when you retrieve data from the database. And Dapper also contains utilities to process data. You can also use transactions and SPs with Dapper. There are a lot of good material about Dapper on the internet. In this example, we can see how to use Dapper to update an existing table row from the database. First we declare dynamic parameters, then we create an SQL command, and finally we execute the query. Remember to use using statement to dispose objects. Dapper has similar syntax with insert, delete and update statements. Next, we use select statement to retrieve data from the database. In this example, we return the row from the person table with given ID. The Dapper returns a row as a person object from the database. You can also use anonymous parameters and anonymous results with Dapper. In this example, we return the person's first name from the person table with given ID. Next we will see what is Razor Pages and how to use it. Razor Pages follows MVVM architecture. In MVC you have model, view and controller. In MVVM instead you have model, view and view model. Razor Pages has a page, page model and view model. Razor Pages supports tag helpers. With tag helpers, you can use server-side code inside HTML elements. You can also write C# code inside page using Razor syntax. Page model contains code, event handlers, and actions. It acts like a controller. View model instead contains properties and validation. A page model is also a part of view model. You can use unit of work with repository pattern when you create, read, update, and delete data from the database in your application. There has been a lot of discussion about that, where you should open and close the connection. To keep the connection open for as short time as possible, we open and close the connection inside the method in this video. The connection is always recreated when we connect to the database. With .NET 5 and Razor Pages, you can also use dependency injection. This means that you don't have to create a new instance of an object manually when there is a dependency between classes. In this example, we register the unit of work and a mapper interface in the startup file. You can use data annotations or fluent validation when you validate user inputs in your application. You can also create your own custom validators. Data annotations are written inside view models. If you require complex validation in your application, use fluent validation. Razor Pages is all about models. You have data models, view models, and you also have entities in your application. You need a way to map data between models. That is where you need AutoMapper. If properties between models are different, you can also create a custom mapper to map data between models. Razor Pages supports root parameters and query string parameters. Here we can see how to use query string parameters. A hacker might try to hack your application by changing a query string parameter value. That is why you should always use parameterized SQL statements in your application. In this example, we have a link to the person's edit page. The link sends the ID of the person who we want to edit as a query string parameter. Every page model has an onGet method without parameters by default. Here we have added a person ID parameter to the onGet method. The onGet method is called when a user arrives to the page. Property binding happens by default only in a POST request. If you need to show a query string parameter value to the user, you have to use bind property supports get. Next we will look at the application. Let's begin. We have made a simple application for this video. With this application, you can create, read, update, and delete data from the person table. The application consists of 3 projects. The application project, which contains a custom profile class, view models, Razor Pages, and a layout view for the application. The application project also has an app settings file, a program class, and a startup class that contains the configuration for the application. The business logic project contains data models, and a data access layer project contains classes and interfaces that we need when we communicate with the database. The data access layer project has a unit of work class and the person class that we need when we create, read, update, and delete a person from the database. The application uses a default layout view that Visual Studio creates when you create the new ASP.NET Core web application. The layout view has a header, a main, and a footer section. The main section contains a render by the method. This is where every content page opens. The layout view also has a reference to the jQuery and to the Bootstrap file, which you can find under www root folder. When we start an application, the index page opens by default. In this example, the index page contains texts and an image. We can also click F12 to open development tools. As we can see, the index page opens to the main section. You can always click Home link to return to the index page. The header section also contains a person link. When we click the person link, the application opens a new page. From this page, we can add a new person into the database. We can search the person from the database. We can edit the person. And we can also delete the person from the database. The person edit page and the person create page uses data annotations for validation. Next, we can see what happens when the user clicks the delete link from the search page. The search page redirects the user to the delete page. The search page also sends the person's ID. The delete page has a query string parameter. The parameter name is ID. First, the constructor of the delete page is called. The constructor receives the instance of the unit of work class. Next, the onGet method is called. First, the onGet method retrieves a person with a specific ID from the database. The method uses parameterized SQL statement and Dapper. The result is returned as the instance of a person model class. Next, the onGet method maps the result from the person model to the person view model. And we can see that person model and person view model contains the same data. The person view model is marked as bind property. Next, the instance of the person view model is sent to the view. And finally, we can see the result. Next, we can see what happens when the user clicks the delete button from the delete page. The delete page model has a query string parameter. The parameter name is ID. The view has a delete button. The onPostDeletePerson method is called when the button is clicked. The application tries to delete the person from the database with specified ID. In this case, the ID value is same as the query string parameter value. You can use F10 and F11 keys when you debug the code. The application uses Dapper to delete the person from the database. And finally, the application returns the user to the search page. As we can see, we can't find the person from the database anymore. I hope you liked this video. Until we code again. Bye!